Alright, so this would be our notes on measuring in space. If you missed these in class, this is how you're going to get them now without me in class. It'll be fine though. So when we're talking about measuring in space, it's very different than when we measure somewhere else, like measuring from how far it is from Chittana to the school, or how far it is from Kenny Lake to Glen Allen, or even Kenny Lake to Anchorage. The distances are just so greater, so much longer or further than we really are used to. So in order to compensate for that, they've come up with different units that help you work with that in a more efficient way. Because if we look at the sun, this isn't really to scale, but if we have the sun, okay, and the Earth right here. So we could say that the Earth is, we could do miles, 93 million miles. Okay, that's not so bad. 93, and then 0, 0, 0, 0, 0, 0. But if we looked at something like, let's say Jupiter, let's just look that up. And then we see how far away it is. Let's see, what does it say real quick here? Okay, so it gives us AUs, doesn't give us, but it's 5 AUs, and we'll talk about that in a minute. So 5 times further. So you take almost 5.5 times further. So if we go back to these notes, I don't really have a million miles, but we take 93 times 5.5, and then we just keep getting bigger and bigger numbers. If we went out to Neptune, Uranus, even Pluto, the Oort cloud, whatever it may be, we'd find that these distances are just getting larger and larger. So in order to compensate for that, they've come up with some units, and we're going to learn about those today. So the first one, though, is the astronomical unit. Okay, and what that does, it takes the distance from the sun to the earth and makes that into a unit, 1 AU, or 1 astronomical unit. So instead of being 93, we look at it as 1 AU, and then we relate all the rest of the planets to it. So anything inside of Earth is less than 1 AU, and anything outside of Earth is greater. So if you remember Jupiter, when we looked at it, it's about 5.4. So that gives us a number that's a little bit easier to use. So Jupiter's about 5.4. Okay, and then we could do the other ones. We could look at those as well. So in this, for our solar system, our sun and the planets that reside here, that's fine, because it's distances that relate to each other. But if we start looking at things even further than that, beyond the Oort cloud or beyond our galaxy, the distances also start to become unmanageable. So they've come up with another one. It's called a parsec. And this is how they determine how far apart stars are. So we have our star. Some people call it Sol. That's where solar comes from. Some people don't call it anything. Whatever you want to is fine. But how far away is our sun, the main part of our solar system, from another star? And the unit for this parsec is 1 parsec is equal to 3.26 light years. Okay, and that's how far light would travel in 3.26 years. And you think about light and how fast it travels. The speed of light is 300 million meters per second. It's fast. Okay. So how far in a year? 10 trillion kilometers. It's just a ridiculous number. Really far. So take that times 3.26, and you see this distance is great. So when it comes to stars, the distances just increased greatly. Okay. So in order for them to measure how far apart they are, they came up with this unit that we can just get a single number or two, and that's called a parsec. I think our closest star, let's look that up real quick. So closest star to Earth, we'll actually get out of that. If we go here, so closest star to Earth, Yeah, misspelled it. So we look that up. Got a list here. So we have the Sun, Proxima Centauri is 4.241 light years away, which is pretty far, a little more than a parsec. And then parallax, let's see if it has our parsec in here. It doesn't. Okay, so you can also use light years as well. So that's another, we're not going to really talk about that, but so Proxima Centauri is the closest, and it's 4.24 light years away. So we could then take the 3.26 and divide it into 4.24, and it'll tell us how many parsecs it is away. But it's far, so we're talking trillions of kilometers. It's very, very far. Not something that you could travel very easily. That also gives us an idea of traveling in our solar system, and what that really means. They used to look at the moon and think, well, how difficult it is to go to the moon. The moon's not all that far when you start to consider how far away some of those gas giants are and how far some of the stars are. So traveling becomes a more difficult proposition, and most people think the only way you can travel is by attaining this speed, the speed of light, and nobody's done that yet. Maybe in the future. Okay, so if we continue, and okay, we got this last thing here. So the last thing we're going to look at is parallax, and this is something when we're talking about stars like Proxima Centauri, it's 4.24 light years away. How do you know it's that far away? Okay, and they use something called parallax. And it's really similar to the Pythagorean theorem, where if you know the length of A and you know the length of B, you could figure out C, right? You just square them, take the square of this, square of that, and they'll equal the square of that. And that's this equation right here. Okay, and how they do this is they use Earth's location 2 separate times and then determine the unknown quantity that they don't know. And let me show you a picture of that to kind of explain it. Hopefully, this can be a difficult concept to understand, but hopefully this will help you. Almost there. Almost. Maybe. It's kind of slow. Hopefully it won't take too long. That's not it. It's taking way too long. It's not responding. Okay, so we're just going to stop. Oh, there it goes. Okay, so let's get off of this. And then we go here. Okay, here is the idea of parallax. Okay, and let me move this over a little bit. Okay, so the top part here, we know if we stood somewhere and we looked at something, this far away, we wouldn't know how far away it is. But if we take another measurement and we look at it at a certain angle, because this is our angle here. So if we look at something with an angle, and eye it up with our eye and kind of get it in the center, and then we do it again, and then we know how far away this is, we can then use this triangle to help us figure out this distance that we don't know. Okay, so perhaps a little better of a view here. So here's this certain star we see every once in a while, and what they do is they take the Earth and the Sun. So this is 1 AU, right? And then here's this nearby star, right? So then we take this distance that we do know, okay, 1 AU, and again, this is not the scale, so we know this distance, right? And then we can kind of maybe figure out this distance, okay, or this is the distance we actually want to know. But then, so we know this one leg, and we can also figure out what this leg is equal to, right? So then this is the idea, have these two different angled views, and then we should be able to figure out one of these lengths here. Okay, and it's a little bit more complicated, but we're able to do that. So they use this idea of angles and geometry to figure out how far stars are away. They also have some other devices they use as well, but we're not going to worry too much about that. But those are our three main parallax. They just use geometry, Pythagorean theorem, to figure out how far a star is away, which is light years. Parsec is used for that, and then the astronomical unit. Let's just check this out really quick. Here's an example of the astronomical unit. Here's the Sun, there's the Earth, and then Mars is 1.52, and we can just keep going out and out and out. Remember, Jupiter is 5.42 or 4 point something. I think it's 5.4. So, and you can just keep going out, and that works fine in our solar system. Okay, so that's kind of our notes. Hope that helps you. Let me know if you have any questions, and make sure you annotate these and turn them in.